Welcome. We're about to dig into one of the absolute cornerstones of physical geography. Seriously, from the ground under our feet to the phone in your hand, it all comes back to rocks and minerals. So in this explainer, we're going to break it all down, but with a special focus, framing it exactly how you need to know it for your UPSC exam.
Okay, so let's get strategic for a second. Before we even get into what a rock is, we need to crack the code on how UPSC is going to test you on it. Understanding the exam pattern is your first real advantage. It's not just about memorizing facts. It's about knowing how they'll try to catch you out.
And here it is. This slide is basically your roadmap. See the pattern? UPSC wants you to start with the big ideas, like the rock cycle. Then, they want you to connect those ideas to real-world examples. After that, you need to know where to find these things in India. And finally, why do we even care? What's the economic importance? Master this flow, and you're well on your way.
Right, with that blueprint fresh in our minds, let's start building your foundational toolkit. We're going to start with the absolute basics, making sure we have a super solid understanding to build on.
So what is a rock? Here's the easiest way to think about it. Minerals are the individual ingredients, like flour and sugar, and rocks are the finished cake. A rock is just a solid chunk of stuff made up of one or more of these mineral ingredients, and together they form the Earth's crust.
Okay, let's meet the family. Or, in this case, the three main rock families that you absolutely, positively have to know for the exam. Getting these categories straight is going to make everything else just click into place.
First up, we've got the igneous rocks. I like to think of these as the original rocks. They're literally born from fire, formed when molten hot magma or lava cools down and gets solid. They're the primary source, the foundation for basically all other rocks.
Now, even within the igneous family, there's a key difference, and it's a favorite for examiners. It all comes down to where it cools. If it cools slowly, deep beneath the surface, you get intrusive rock, like granite. But if it erupts and cools super fast on the surface, you get extrusive rock, like the basalt that makes up our Deccan Plateau. Simple as that.
All right, family number 2, sedimentary rocks. These guys tell a story over millions of years. They're made from little bits and pieces of other rocks, or even old plants and shells that get broken down, washed away, and then squashed together over time, layer by layer by layer.
And here's the big giveaway for sedimentary rocks. See that bullet point? Fossils, this is the only rock type where you'll find them. Why? Because the whole process is much gentler, without all that crazy heat and pressure. So remember this. If you see a question that mentions fossils, your brain should immediately go to sedimentary. It's a classic clue.
And last but not least, our third family, metamorphic rocks. Now this is where things get really cool. You take any existing rock, could be igneous, could be sedimentary, and you put it under immense heat and pressure deep inside the earth. It doesn't melt, but it completely changes. It transforms into a brand new rock.
Okay, pay attention because this table is pure gold for those match the following questions. It shows you the family tree, right? How simple limestone turns into elegant marble. How tough granite gets squeezed into gneiss, and, incredibly, how coal, under just the right conditions, becomes a diamond.
So we've met the three families, but how do they all relate? Well, they aren't separate. They're all connected by something called the rock cycle. Think of it as Earth's giant, continuous recycling program. And for UPSC, understanding this concept is absolutely vital.
And here's how it works. You can jump in anywhere. Magma cools into igneous rock. That rock gets weathered down into little bits of sediment. Those sediments get compacted into sedimentary rock. That rock gets buried and cooked into metamorphic rock, and that rock can melt all the way back into magma, starting the whole thing over again. Getting this flow is a game changer. It shows you have real conceptual clarity, and that's exactly what they're looking for.
Okay, theory's done. Let's bring this all back home to India and see how it applies on the ground. The distribution of key minerals across the country is a topic that comes up again and again, especially in the prelims. This is high-yield stuff.
But wait, before we get to the map, let's just lock in this definition. If a rock is the cake, a mineral is the pure ingredient. It has a specific chemical formula and a crystal structure. It's the pure, fundamental building block. That precision is what makes it a mineral.
All right, this slide is pure, high-value information. You just have to know this stuff. Knowing that Odisha and Jharkhand are the heartland for iron ore, or that Andhra Pradesh is key for mica. This isn't just trivia, my friends. This stuff translates directly into marks. Seriously, this is one of those slides you should probably screenshot.
Okay, we've covered a ton of ground. So let's do a quick rapid-fire round to really lock this knowledge in.
This is all about cementing those core concepts so you can recall them in a split second. You ready?
First up, igneous. What's the key phrase? Cooling, magma, or lava. Got it.
Next, sedimentary. Think layers, deposition of sediments. Done.
And metamorphic? The key word is transformation, heat and pressure. Simple.
Finally, the rock cycle. What is it? It's that continuous process, the engine that connects them all. Perfect.
So, I want to leave you with this final thought. Mastering this topic isn't just about passing an exam, it's about understanding the literal foundation of our world. These are the dynamic pieces that have shaped our planet, built our entire economy, and formed the very bedrock of civilization itself. Why does it matter? Because it's everything.